Hi everyone, are you able to hear me and see my screen clearly? All right, great. So question from David is that can we look at big data example and how all the pieces fit together? For example, ZooKeeper, HDFS, and everything else. Okay. Interesting. So let me, okay, I think this is a very important question. I know that you may not get it in the single time, but we'll put more context into what we're talking about. Okay. So I'm going to, all right. Great. Let me try to explain the a typical project, and probably that will answer your questions. Okay. Okay. So yes. Let me. Okay. So yes, let me try to describe this in detail. All right. Should I take a standard case of, say, the kind of problems that I've solved, and probably that will give you a clear picture. Okay. Now let me just open my drawing one. All right. So great. All right. So let's take a case of say recommendation engine. Let us say you are working in an organization which is having a website, an e-commerce website. Okay, let's say an e-commerce website is there, right? And what do they want to do is they want to build their reconciler engine. Okay, so or it could be it, it could be a software company or a software services firm which is trying to support a client who wants to build the reconciler for their customer. Okay, so basically the end goal is to build a reconciler. I'm so sorry. Not reconciler. We are talking about recommender engine. Reconciler is going to be a little bit different. Okay, so it's an e-commerce firm and we are trying to build a recommender engine, not reconciler, recommender. Okay, and let me take this out. Okay, so what's a recommender engine, or we also call it collaborative collaborative filtering. Okay, so in this kind of thing, say you want to build a recommender engine, so that first of all you must understand the end use case. Okay, first of all you must understand the end use case, as in where are we going to display the recommendations. Okay, so and where is my data? Okay, where is my data, and where are we, what is the end objective? Okay, so these are the first simple question, and that we start with. Now the data is say the data is say in the log files. Okay, what is log files? Log files on a web server, when the web server is trying to serve the user, the web server is somebody like Amazon.com, where you open the website and it makes a note of which URL was accessed by you. And that note is done in a text file. And those text files are called log files. Okay. So first of all, in an e-commerce website like this, you will have say 5 servers running concurrently. Okay. So let's say this is my web server 1, 2, and 3. Okay. So these are our web servers. Is a question clear? And what we want to do is we want to display. You may also like this. Okay. You may say 10 items, 10 recommendations. Okay, that's what you want to give to the end user. So this is where is your data? Data is in log files, and what is the end objective? Display. You may also like this. You may also like these. Okay, so something like this. Now, clear? So the data is in the web servers. Now these web servers are continuously writing data. So we need to take this data to a central place. Okay, the data is in the files. So we'll first of all take this data to say HDFS. Okay, we'll take this data to HDFS. Now, from everywhere, we need to take the data continuously to HDFS. And for that, what is it that we're going to use? We are going to use a tool called Flume. Okay, a tool called Flume. Flume is exactly used for this. So everywhere we will put the Flume agent on all these machines, and it'll keep on pushing the data to HDFS. Is it making sense to you? So we are just talking about a typical use case whereby we have web servers and we would like to generate recommendation. For recommendation, uh, we we would like to generate 10 recommendations, okay, based on say last 15 days of history. Okay, based on last 15 days of history or human user behavior, we would like to understand. So first of all, we did this. We went to the web servers, each of them. We installed the Flume agent and configured it such that it keeps on pushing the data to HDFS. Now in HDFS, you're getting all of the data in a single folder, right? Then we will write our program. Okay, say let's say we are using say Spark, okay, or we are using say Hive. Hive we'll use later. So first of all, we will use say Spark to process these these files. Okay, so our Spark script, okay, Spark script basically would run. How would the Spark script run? On top of inside the Spark, and then this will be running on top of the yarn, on top of the yarn. Okay, so Spark script will run on top of yarn, and what it will do is it'll read the data from yarn, from HDFS, and put back say cleaned up data. Okay, so we'll call it log parser. So we call it log parser. Log parser is something which converts the logs generated by the web server into a tabular structure. Okay, so say after this work, let's say it's putting the data into something called say Hive. Okay, these boxes basically do not represent the location of each of the systems. Okay, these boxes do not represent the the location because HDFS, Yarn, and Hive, mostly they will be running on the same system. These are conceptual building blocks of what we're doing. So our Spark script, which is running on Yarn internally, is going to pull the data from HDFS, save the table. Okay, so it's going to convert that into Hive tables. Okay, now once we have Hive tables, we did a couple of things. One, we made our data queryable by the end user. Okay, so that if there are analysts who want to understand the user behavior, they can just query Hive by writing SQL and generate some kind of they can take a look at the data. Okay, so at this point, the various what we call analysts, okay, would analysts, okay, various analysts would read the data, basically interact with Hive, and various analysts will interact with Hive, and they can also extract this information, right? This is just one use case that we're talking about. Now, so once we have the result in Hive, what we will do is we can run, let's say, this is just one example. Now we can write, okay, they can interact using SQL. Okay, they can use SQL in order to do the analysis, and they can also use tools like Tableau, okay, Tableau or BERT or any other BI tool, Crystal Report or whatever. They can take a look at the data whenever they want. Now, once they have this, what we can do is we can, once we have converted this into this, then we can further write our MLlib program, okay, which can read data from Hive, okay, which can read data from Hive and generate the recommendations, okay, generate the recommendations and push it to the database. Okay, on these machines, let's say there is a database also running, or let me just draw a database. Okay, this is say our web server database. Okay, generally database is kept on different machine than the web server. Therefore, I've drawn it separately. These are reading from it. So MLlib script or Spark MLlib program. Okay, Spark script or Spark package we'll create, and then we'll basically use it will use the MLlib package to generate recommendations. All right. So what you see here is this. Now, at this point, we can, once this is done, then we can save the results in, say, database. It could be, say, MySQL or something. So from here we can save, and then let's say this side is the user, this side is the user. Okay, and user basically accesses any of these web servers. He will also get the recommendation served by the web server. Okay, so web server is something like this, and web server will basically read the data from MySQL as usual. Okay, so now what we see is HDFS is used. Now HDFS is also used by Hive. Okay, Yarn is being used by Spark under the hood, and tables are being created on Hive as well, and so on, right? So you'll notice that in these circumstances, we have only used a couple of tools. One is Spark, other is HDFS, other is Yarn and Flume and Hive, right? Now, these script that you see over here, this is one script, right? This is, say, one script, and this is another script, right? They they can be scheduled. They can be scheduled by the way of UZI. So let me just mark them as 1 and 2. Okay. So if we have, say, UZI here, okay, UZI, UZI can be used to schedule these two things. UZI can be used to schedule these two parts. Okay, I'm really bad at drawing, but okay. So UZI can be used to schedule these tools. So what all have we used so far? We have used HDFS, we have used Yarn under the hood, we have used Spark, we have used Flume, we have used the Hive, and so on. Okay, let me repeat what I've just talked about. There are web servers which are generating the log of the user behavior. Like when you click on a link, when you go to another link, and so on, it keeps a track of who is clicking where. So that most of the data is being recorded as part of Apache logs, and that Apache logs is kept in a file. Okay, Apache log in Apache is the web server's name, and now it has become a license as well. That okay. So generally, the web servers are either Apache web server or Nginx. Nginx is kind of a router. Okay, so we have many web servers. They are running and they are generating data. Now we want to pull the data from all of these web servers to a central location. So we use Flume to push the data from each machine into HDFS so that this data comes here continuously. Now, the next thing we do is that we use our Spark script, which basically read the raw data from HDFS, cleans it, creates tables out of it, saves it in Hive. Now, our another script will load data, although both of these things could be done in a single script. But why we have created it in two-step? So that we have intermediary table, which analysts can use. Okay, analysts can use for reporting other individual behavior, right? So here at this point, this second script, the one that is going to really generate recommendation, is going to again read the same file, and once it is done, once it has done generating recommendations using MLlib package, which is out of the box available, it will save the results into MySQL, and from there, the data, the recommendations will be served to the end users. Okay, web server will read this, serve to the end user, or present to the end user. Okay, did it make sense to you? Any questions on this? Now, there are a couple of tools that we have not used here. One is, say, ZooKeeper. We have not used ZooKeeper. Second, we have not used, say, HBase. And we have not used, say, Scoop. Yeah, actually, you could also use Scoop to generate to copy the data from Hive to MySQL. Okay, but we did that using Spark itself. Okay, so now question is that where does ZooKeeper fits in? So ZooKeeper is internally used. ZooKeeper is used by Yarn internally. ZooKeeper is used by HDFS internally, and ZooKeeper is also used if your Hive is load balanced. Okay, so ZooKeeper is kind of powering all of them. Good. Question from David is, thus, ZooKeeper is temporary work areas for those tools? Yes. So those tools use, all of them use ZooKeeper for their coordination, because Yarn has multiple machines. Similarly, HDFS is running on multiple machines and need to do the load balancing. Similarly, Hive also has same thing. Okay. All right. Okay. So can I send this chat to you? Or it doesn't let me. Okay, so can I do the full screen here? Uh, okay, this is good. And okay, now I can take the screenshot. I think, yeah. All right. So a question was from Prashant. Question was practically which data is getting used by web servers from MySQL? So yes. So MySQL, see, generally these web servers would be keeping their database somewhere in the database, right? Alongside, we create one more table, which basically represent our recommendations, per user recommendations. And using this script, we basically update that table for each user. So when the web server wants to present recommendations, all it has to do is query the database table and present it. So the recommendations are not being generated on the fly. Instead, these are being periodically calculated once in a day, and then the and then given to the web server. Okay, did I make sense, Prashant? A, a question from Sachin is, can you explain the Flume is exactly? Yeah. So there could be two ways to get the log files from web server. Basically, here the log files are continuously created by the web server. As in, when you click on a website or any web request is catered by a web server, it makes a note of which request has been catered, and it is appended to a file. And that file is called log file. Now, this log file is being generated continuously on all these machines. One thing which we could have done is every day when we are about to run our recommendation engine, we will basically copy the data from all the web servers to HDFS at that point of time. That's going to be very, very slow, right? Instead, what we do is we use something called a Flume Agent. What Flume Agent does is it keeps on reading a particular file, it keeps on chasing a particular file, and then keep on pushing that data to HDFS. That makes the logs available on HDFS within fraction of seconds or within like couple of seconds. So that's the role of Flume here. Flume is run on all these web servers, which will keep on pumping the data to HDFS. So Flume is a service running on all the web servers. It's a very lightweight program that's running in the background. Okay. Alok and Sachin, did I make sense with respect to Flume? Okay, I'll save this screen, and if Okay. A question from Sachin is, do you think that here we can fit app server as well, like WebLogic or IBM? Yes, yes, that's right. That's right. We can, instead of web server, we could actually fit in app server. That's right. A question from Robin is, what is the source of Hive for analyzing data? Is it HDFS or Yarn? So the data here, basically this script. So Yarn has nothing to do with our data. Yarn is basically like a operating system of the computer, which will run our programs. Okay. So here, what you see is this Spark script is what is converting our raw data from HDFS and creating a table out of it and saving it properly in Hive. Okay, it'll have a column with the user ID or identifier, timestamp, IP address, or some other data, some basically cleaned up data which is relevant to us. So it'll basically do the cleaning up of a data to a very large extent and then keep it here. So the data is written by our Spark script. So the script that we wrote here, which will read data from HDFS, process it, and save it in Hive. Okay. A question is, if yes, then where and how do we set the capacity of storing the logs? So this HDFS basically is capable of storing petabytes of data. Okay. And in the background, you see the background Hive also is storing data in HDFS. Okay, Hive basically stores data inside HDFS, just that it provides a tabular structure. A question from David is, the web server logs have what the user has clicked on. So every web server has that information. Okay, so clicked on as in the mouse cursor is something not generally available until you basically track the mouse cursor also. Okay, but every page that you visit, web server log generally has that. Okay, either get request or post request. Get request is when you load a page, and post request is when you submit something. So all of those requests that you make to the web server is by default available in the logs. So question from David is, so what is that data being used to generate recommendations? Good question. Good question. So, okay, let's just, I know that it's a deviation, but it's a very important question, and that will actually help all of you. Like the way we did in our machine learning course, what we did was we started from the project, and that was quite useful. We started in a similar way. So I think it's a very good question to answer right now, so that we all are in the perspective that the kind of uh, problems do we face. I will also, it's okay to, spend maybe half an hour more on understanding the utility of each individual product. And even if you get it partially, then also it's going to be useful. Okay. All right. So the question is, what data is being used to generate recommendation? Let me just show you an example process. Okay. So let's take a look at what MLlib. There is a tool called MLlib. There's a library of Spark called MLlib. What it expects you to do is create your data in the form of a table, okay, such that it has three columns, I'm just talking really simple. I'm not going into detail about machine learning. It's just a very simple thing. So this data, the way MLlib expects is, yes, MLlib is machine learning library from Spark. Okay, so we'll use MLlib for the, let's say, generating recommendation. So the expectation of MLlib is you prepare a table which has user ID, product ID, okay, and and we have user ID, product ID, and we have ratings out of 5. This is the expectation of MLlib is. So basically the MLlib is reading the data from here, from this table, and generating another table for us. Very similar table, okay? It generates a very similar table, okay? Okay, same work was earlier, the way we did at, say, InMobi, we used Mahat instead of MLlib. Okay, that's what I used there. So what it gives us, the user ID, recommended product ID. This is recommended product. Okay, this is a recommended product ID. Okay, this is the recommended product ID and the suggested ratings. The suggested rating. What does it mean by suggested rating? Suggested rating means that this user will like this product how much. Okay, so but question is that how will we prepare this? How will we prepare this kind of a table? And if you take a look at, say, a typical log file, the log file would look like this, right? Log file will look like this. Okay, there'll be say timestamp. Okay, there'll be a timestamp. Then okay, then there will be there'll be the IP address. There will be the URL, and there will be maybe a user ID. Okay, user ID. Okay, so this user ID visited this URL at this time, and the IP address of the user was this. Correct? So how will we convert this kind of data into this kind of data? It's a text file log. Let me just put a .txt here just to emphasize. How will we convert this into this? So first of all, what we are going to do is we're going to clean up these records. Okay, we are going to do many things here. So the step is, this is the kind of step we are going to follow. Number one, clean up data where user ID isn't available. Okay, or any of the fields are not available. So we just clean it up at that point of time. We remove those records. Second thing we do is we group the data based on group the data based on URL, or okay, clean up the data, extract only the records where user visited a particular product. Okay, so let's say you are a user, you have been visiting a website. So we'll first of all just extract only the widgets where you have visited some product, not the general pages. We will skip the search results and other parts. So we're just trying to be extremely simple. Okay, so we are extracting only the lines, okay, where user visited a particular product. Okay, only those lines. Now group the lines based on user ID, product ID, and prepare the counts. Correct? So this user visited this product this much time. Okay. Okay. So it'll be in the beginning, it'll be like David visited this particular shoes these many times, and so on. Right? So, and at the end of it, it'll be like uh, David sues 500, right? Or not sues a particular model of sues. Okay. So there afterwards we normalize the results. Normalize the results. Okay. So that 1500 becomes out of 5. Normalize and bring it to out of 5. Okay, so we basically standardize and normalize the result. For, so when I say Sandeep visited, say Sandeep visited a particular mobile 20 times, so 20 need to be converted something between 1 to 5. So we need to kind of average it out, find out the max and min values of each product for each user, and then basically divide it by the max and min and convert it into out of 5. Okay, so once this is done, once this part is done, what will happen is, so we are going to read data from this side and write data into this and so on. Okay, so this is our first step, this is our second step, this is third step, and from here there'll be further, we'll write it to high. Okay, is it clear to all? So a question from David is, so what you're saying is that several users have purchased or rated an orange widget as 5-star. The next user puts in their cart blue widget. Okay, since the other users have purchased orange widget, then the blue widget purchaser would be giving a recommendation of purchasing an orange widget. Correct, correct. So it is of the same form. All right. So this is basically there are many more ways of generating recommendation. I've taken a very simplistic case whereby we don't have ratings available for each user. Okay, we don't have ratings available for each user. Instead, we are inferring the rating. So generally, this rating is a composition of many factors, and this is where we need to figure out what are those signals of user's preference. First signal is, if you're lucky, then user has really voted up or down a particular product or given it some kind of rating. You are really lucky in that case. But in real sense, you must prepare the ratings by composing many ratings, such as user visited pages, user spent this much time on this product, user has added it to wish list, user has added it to cart, user has shared the link with other people. So we consider all of those signals to see if the user really likes the product or user has bought the product. So all of those signals you should consider while generating these ratings. So these ratings are yours. Okay. So once you prepare this user ID, this user likes this product this much, this user likes this product this much. So we prepare this kind of a table by processing the data. Once this is done, and things are looking great, then we can feed it to MLlib. MLlib will automatically figure out the recommendations based on this, because all it will do is it'll find the similarities between the users and based on the products and their ratings, it'll find the similarities and then start giving recommendations to each other based on the similarity. So if it finds that me and David are very similar, then it'll be recommending this one. Okay. A question from Bintao is, could you recommend a Hadoop textbook? So two parts. One is the definitive guide is good. Definitive guide. Okay. So guide of Hadoop is good. All right. This one. Okay. This is only for Hadoop. While for Spark, there is a book called Learning Spark. I find that to be useful. Okay. This, yeah, this one. And the third one, which I find useful, are the individual components, their documentation. So rest is based on the documentation. Okay. So I hope this is clear to everyone. This is a processing step that we need to take in case we are generating the recommendations. All right. So this is the standard batch processing kind of system whereby we are doing the static processing, as in there's no production impact on anything, right? In some cases, let's say you want to move your e-commerce, okay? Let's say here you realize that MySQL is not sufficient and you want to replace MySQL with some Hadoop tool, then probably part of the data you will be moving to, say, HBase, okay? So the cases where you have millions of requests coming in that case, you will be moving the, let me copy this. Can I copy this? Okay. So, right. So this was the one use case. Before jumping further, is the approach clear to you? Any questions on this approach? So we talked about specifically two approaches. One, so we actually talked about only single approach. And here we talked about a general architecture. Here we talked about exactly what goes in collaborative filtering. A question from Noor is, what is the version of Spark we're going to use? We're going to use both Spark 1 and 2. Whenever needed, we'll move to Spark 2, and we'll use the default one, Spark. Okay. 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 Yes, that's a problem. Thank you, Noor, to bring out that point. Yes. So that's one of the reasons why we are kind of not able to follow that book beyond a point. That's where we are going with the documentation. And so learning Spark is good for up to only certain extent. Afterwards, we need to focus on using something else. Okay. Now, a question from Robin is it possible to set up HDFS system to an on-premise private cloud, then capture and parse data analytics such as Google Analytics for certain products, marketability, which I would like to analyze? Yes, you can definitely do that. You can actually, let's say your data is not too high on your website, then you can actually enable right away the web server analytics and do that. But if you want to do the analysis by yourself, like the way we need it in case of InMobi, then definitely you can set up your on-premise private cloud and do that. Okay. I think now you can take the screenshot. This is good enough. A question from Sachin is, can you explain again how the other table is created by MLlib? It's not created by MLlib. It will be created, we will be using the MLlib and our script will be saving this data. MLlib will generate this table and we can save it there. So MLlib, the way it's going to work is, it's going to take a look at this data, find the similarities between the users, and start recommending products to similar users. So if me and you are having a similar behavior based on what products we have liked, then it will give me and you, it'll give me and you each other's recommendation. Okay, that's generally the collaborative filtering. Okay, is that your question was? All right, great. So this was one use case. All right, so let me just save it somewhere so that I can upload it. All right, now let me talk about, this is done. This is done.
Sandeep,
Yeah,
this is Alok. I have one question.
yes, go ahead, please.
So, like we have discussed there, like we have for the web server, we have the Flume
Mm-hmm.
to read the logs. So, actually, I have doubt that there how we can connect with the Flume to the web server. Like
Okay.
so, like earlier, what we have like Elasticsearch, we have the log connectors there. So we when we uh, when we configure the log4j XML file like logback like something,
Mm-hmm.
so we have given some connector there, appender kind of connector. So automatically it will push into that like into the Elasticsearch kind of things
Mm-hmm.
in the log configuration itself.
Right,
The
right.
Flume is work in that way. Like if we have the
Correct, correct, correct.
log4j like XML, in that if I give the appender kind of or connector, so directly it will go to persist the data into HDFS, or it is a program that will run backend and read the log file and then pushing into the HDFS. So
So
how?
your first question, first assumption is right. First
Okay.
hypothesis is right. Just like the way you configured in the XML, the appender for the Elasticsearch, in the
Okay.
same way, you will configure the Flume appender in which your log4j will push the data to Flume directly. Flume Agent is a service that's running and listening on a port, reading the data from user or from whatever possibilities on a network port. And there are hundreds of possible sources that we call for Flume. And Flume can actually even chase a file. Let's say some user is writing into a file, then Flume can continuously chase that file and keep on incrementally push there to the HDFS. So yes, most likely the way you have suggested, that's the way we will do. In case the sysadmin is not allowing us to update the log file, what we will do is we will just chase the log files. Okay, in case the sysadmin is not allowing changing the XML file.
Okay. Okay.
Okay,
Yeah.
all right.
Yeah.
Wonderful question.
Thank you,
Wonderful
Sandeep. Thank
question. Great. All right. So yeah, that was a great question. Now, and yeah, did I skip anybody's question? Robin was able to answer your question. Now, should we move on to another use case scenario? All right. A question from Robin is that I'm interested on Sparks. What are the other scripts that we may set on Sparks beside log parsing? And what are the other functionalities of Spark? So here, basically, it provides you the full functionality, just like whatever you can do with normal program, you can do that. So this script can be written in Python. This could be in Python. It could be in Scala. It could be in Java. It could be anything, right? When I say script, it doesn't necessarily mean a script. It could be a package written in Java. It could be anything. So here, whatever you can achieve using any programming language, you can achieve the same thing. Here we have just written the log parser script, but in production, it could be really as complex as, say, machine learning here. This is again a Spark program. It's again a Spark script, which is doing the entire weightlifting of the uh, the complex structure. So you will be doing normalization like this. You could be grouping. All of this code you will have to write. Okay. Is my voice clear to others? A further question from Robin is, will the output of the log parse be in CSV? Can we set to the other format? We can set to any format that we wish to. Okay, that's what we will learn as part of Spark. Spark provides you really powerful way of computing. Okay, whatever you can do with Python, Scala, Java, or any other provided libraries, you can do in Spark. Okay, so basically, unlike say Pig and Pig Latin, where we were limited by the script or the syntax or construct provided by Pig, here we are not limited by that. Okay, in case of Pig, if we are limited, we would always end up creating our own commands, and we will end up writing a lot of Java code. But here, you don't need to do that. Okay, it's really simple. Yeah, go ahead. So a question from Noor is, yeah, go ahead, Noor. Another question from Robin is, in actual setup, is this Spark tool free? Yes. The interesting part is that even though Spark would run on top of the whole cluster, when it runs your script, it is going to utilize the cluster. But interestingly, it will not, what do you say? It will run on top of the cluster. You don't have to worry about sending it to all the machines and so on. It'll automatically run your script, these scripts will run on top of multiple computers on top of Yarn. An interesting part is that you don't have to install Spark on Yarn. Let's say you are using Hadoop cluster and you're very happy with the Hadoop cluster, but the new work that you're executing requires Spark. So you can still submit the Spark program to the Yarn, and it will automatically install the Spark on all the machines wherever it runs for the purpose of executing your code. So you don't need to explicitly install Spark upfront on all the machines. Okay, that's a very important thing, because let's say you're coding in Spark and your system admin says that, hey, our cluster does not have Spark on there, so we can't really launch your program. So you can always say that, hey, my Spark program does not really need to be, Spark does not need to be installed on the whole cluster. While you execute the program, Spark will be installed by Yarn automatically. All right. Okay. A question from Noor is, in your example, we are extracting meaningful features from log by data wrangling process. That's right. What if we have captured these features directly to a database from user session, avoiding the log file, like writing, parsing, cleaning the data in the web job? That's good. That's a very good point, Noor. Noor's point is that we are trying to kind of doing a lot of processing to clean up that data, right? Now, question is that can't we just save this instead of writing on the text file? Can't we just push it to some database? Push it to some database. The answer is that one, when you build such kind of a process, the chance of this working out is very high, because almost every website, every web server has log files, correct? Now, the second thing is, When you are running a web server, when you're running a web server and you're writing the data to the database, right? So there are two things that are at play. Let's say in here, you are putting the each web server is putting the data in the MySQL, right? Upfront. So first, the database are costly. Okay. So the maintenance is costly. So you generally do not put the less costly data, less important data to a database. Okay. Instead, you basically put it in file. So most of the servers actually don't want, system admins would never like to spend databases for keeping the log files. Okay. Second, log files are you have to have a great turnaround time. If there are millions of users on your website, you can't really afford to keep on writing, keep on delaying the users because of too much time being taken to write the log file. Okay, because there is inherent overhead of dealing with the database. Therefore, every time you try to write something, some log message, it's going to take a lot of time. Therefore, database is not suggested in case there is a huge traffic on your website. Good question. That's right, Maruk. I think that's what you answered. Okay. A question from Hitendra, is Spark part of Hadoop ecosystem or add-on? Spark is a separate product, a full-fledged processing engine designed on the same principles as Hadoop MapReduce. Okay. Earlier, this part that we are doing here, in case of our InMovie work, we did this using Hadoop MapReduce. Okay, the same part was done using Hadoop MapReduce instead of using the Spark. Okay. Noor was able to answer your question. And okay, Hitendra. A question from Maruk. We need more database server. It's costly solution. I guess that's right. We do not write logs in database. That's right. Grishma's question is, what if the data is related to placed orders? It won't be saved in database. It will be saved in database. That's right. So transactional data, you will always keep in database, not in the logs. Logs are for, say, append only kind of data, like where you are just appending and forgetting. Okay, for those kind of things, we generally put in the logs. But orders, you will keep it in the normal database. At that point of time, let's say you're here, let's say at this point of time, let's say you want to do an analysis. So you might have to pull some of the data from MySQL to here. Okay, to MySQL to here, let's say orders, ratings, and other things, you might have to pull it here. And that can be achieved easily by using a tool like Scoop. Okay, using a tool like Scoop. All right. So a question from Noor. I'm not advocating to write the complete log files to database, okay, but just 3 features which are important to the business to database, and this will save us parsing the big file to extract 3 features. That's right. That's right. Okay, that's right. So you could do that. You could do that, but in principle, if this is really, really urgent, only then we will do that. Otherwise, let it be, because the way the companies work is that, I mean, even in our case at InMobi, we never knew that we will be doing recommendation engine at the time of launching our ad serving engine. Okay, but we were just recording entire thing. Had we not recorded the past, we would have missed out on so much of data. Okay. All right. Good. Very good set of questions. Question from Hitendra is, so Spark has to be installed after Hadoop? Not really, not really. Spark will be installed automatically when you launch the program. Okay. So that's the clever part which Yarn has done, that you can actually run any kind of application on the server. It will automatically install. Okay, so Spark is not part of the ecosystem. That's right. It, Spark is a separate tool and is basically from a different company, supported by different company, but it operates really well with Hadoop ecosystem. All right, wonderful, wonderful. So these are very good questions, very important questions. Now, next question is from Robin. Can you give us an example of use case of public web server database that can be accessed online for analyzing a product, etc., using HDFS and Spark? For instance, me as a user with knowledge of HDFS trying to apply a simple product data and log analysis. All right, all right. What I'll suggest is, actually this is far more easier. Okay, so if you go into my course, okay, so if you go here and let's say in one of the courses, you will notice something called a Hive project. You can start fiddling around with this. Okay, you can start fiddling around with this. Okay, so take a look at this, and I think it has started showing some ads. The comment system has started showing the ads. You can skip the ad. We are trying to create our own commenting system in the meantime. Okay. All right. Wonderful. Wonderful. So a question from Robin is, can you give us an example of use case of public web server? Okay, I think you can do this one, and this will give you a good picture. All right, so that's one thing. Now, next one is from Noor. What I understand is that Spark kind of replacing the Hadoop MapReduce path. That's right. That's right. Okay, so most of the computation part where you need to do the computation processing has been moved out of Hadoop into the Spark. A question from Sachin: Spark is not in Hadoop ecosystem? No, it's a separate product. Okay, can we really execute the use case which you shown? Yes, we can do that. We can do that. Okay, we will actually go into each product at a later time, but you can definitely do the same thing. All right. Great. So this was the kind of a data pipeline that we talked about. Now, there could be two more situations. Let's say you have a web server which is really, really busy, and what you need to do is instead of using MySQL, you realize that MySQL is not able to handle your kind of data. In that case, some of the data you will sift to HBase. Some of the data you will sift to HBase. Okay, HBase or any other NoSQL. Okay, in that case, the recommendation engine will run on top of this. We'll read the data from HBase and do that. Okay, good. So that could be another use case, and from there, the pipeline, rest of the pipeline will remain same. Okay, and yeah. So this is a huge amount of change actually. We took a long time at Amazon to move the replace the normal as Oracle database with a NoSQL database. It took us a long time, and still the transactional data is still with. When I left 2-3 years ago, at that point of time, the transactional data was still in the database. Okay, in the normal database. Okay, we'll talk about NoSQL. NoSQLs are the databases which run on top of multiple computers. Yes, which run on top of multiple computers. So these are distributed databases. Okay, now this is one case. Now there is another use case which is also quite popular. Let's say we want to do some kind of a real-time fraud detection or real-time operational intelligence. We call that operational intelligence. So imagine that. Okay. Okay. So question from Sachin is how we should execute this use case in real time. Yes, we will talk about this as we go. All right. As we go, we'll basically do hands-on on each of the components, and then by the end of it, you'll be ready with this. Okay. Now, the other thing that I wanted to discuss was the third kind of project work, third kind of architecture. Imagine that. Okay, I'll talk about let's say one of my works at Amazon. The idea was to optimize the images. Okay, so what happens in the organization is that we generally have a queue. Okay, we call them message queue. Okay, message queue. And on one hand, people keep writing to it. On the other end, people keep on listening to it. Okay, so basically in a message queue, there are topics and people could write on various topics. Okay, people could write on various topics. So this is basically, these are the topics that I'm trying to define. So multiple people can write to the same topic, multiple people can read from the same topic, and so on. Okay, so basically this is the another kind of architecture. The earlier processing was batch wise. This is continuous, or we call that streaming process. Sometimes we also call it unbounded data processing. So in my case, all the vendors, okay, all the vendors were updating the page, updating the product details at Amazon, and what they were doing is they were continuously putting data. These as soon as the page is updated, the page admin tool, the admin tool using which the vendors were updating the page, the information like the image of the product or the details, the bullet points, the descriptions, and so on. So as soon as vendors were updating the product, an event was being generated, and that the way to do the event was to put a kind of message in this queue. Okay, so in this queue we'll say that updated product 1. That's all. This is one example of message. There could be many messages going in this queue, product 2, and so on. So there are many messages that would keep on going into this queue when users are basically changing the product detail on Amazon. Not users, when vendors are updating the details. So at every update, we receive the various messages in a queue, and then we process these messages, and based on these messages, we take certain actions. All right. So this is basically another kind of scenario here. Generally, people use tools like SQS, which is hosted from Amazon. This one is, there could be Kafka. We'll talk about Kafka, and we'll do the hands-on with Kafka, and so on. On the other end, we can consume this data and process this data using, say, Spark streaming, or using, say, Storm. or using the Kafka also provides a processing engine. All right. So using we can basically there could be many processors or many producers of data. They will keep on writing to it and continuously will keep on getting the updates. This is essentially the publish and subscribe kind of model. Thank you, Hitendra. Okay, so this is the second architecture where we would be requiring the Spark streaming. Also, from here, we could be writing continuously to say HDFS, and so on. So basically, this is a continuous flow. Okay, continuous flow. And generally, we call it in very simple word. We generally have any organization, the general flow of data is kind of forms a lambda. It forms a lambda. The the user's event came from here. One copy. So this is some message that has come from the user or some event that has happened. One copy goes to HDFS. Other copy goes to our usual queue or message queue. So this is also called, or let's call it, say, analytics platform. Okay. Uh, this message queue would be coming through Kafka here. Say, this is a Kafka. Okay, this is Kafka till here. Okay, from there, this analytics platform is also reading, and one copy is going to HDFS. So this is also called Lambda architecture. Okay. So in very simple words, when there are users writing to it, one of the process would be writing to HDFS, other would be processing. So this is basically kind of forms a lambda, and therefore we call it lambda architecture. All right. I hope this is clear to everyone. Yes, it means that we can use Kafka processing and Storm processing instead of Spark. Just that Spark provides very robust engine, which is able to do very complex things like machine learning using many computers, which neither Kafka nor Storm is able to provide. All right. Just that Spark's streaming is the latency is generally somewhere between 1 to 5 seconds. Therefore, people who need the response time of lesser than 1 second, they generally go with Storm or Kafka processing. Okay, so Spark is owned by Databricks. No, Spark is an open source tool hugely contributed by Databricks. Okay. All right. I hope you got the picture. A question from Robin is, so Spark is already capable of deep machine learning. It's not capable of deep machine learning yet, though they are experimenting with the deep neural networks, but it's not yet there. Okay, though most of the machine learning works, it can handle pretty well. Question from Noor. So Kafka is also a processing engine like Spark. We would be using some kind of language over Kafka similar to Spark. Yes. Okay. A question from Prashant. Sorry, when to use Kafka, Storm, and Spark streaming. So I'll explain again. So Spark streaming is really powerful. It provides you all kinds of libraries, machine learning libraries, data science libraries, and ability to parse all kind of data. And the interesting part about Spark is that anything which Java can do, it can do, because in Spark, all the libraries of Java, in Scala version of Spark, all the libraries All the libraries, whether sending an email, writing to RDBMS, all those libraries are available upfront because Java has a very exhaustive support across the world. Therefore, everything that can be done in Java can be done in Spark. Second, therefore, it opens door to a lot of innovations, lot of things, which is really hard to achieve using Kafka processing or Storm. Second is the Spark streaming is so Spark streaming is powerful, but there is a latency of somewhere between 1 to 5 seconds. So when your requirement of latency or your requirement of TET, as in the time it takes to process a record, is below a second, then do not use Spark streaming. Use Storm or use Kafka. Wonderful. Great. So this was these were very good set of questions, and we will keep visiting these architectures. Let me also keep a copy of these. All right. We're recording these sessions. Okay. Just to be, generally going over video is a little more painful. That's why. Okay. All right. I think I have saved this one already. All right. So wonderful. Wonderful. So a question from David is, there seems to be a lot of overlap between the tools. Is there a chart or diagram showing what tools can be interchanged? Interesting, interesting. So let me just take it as a homework. Okay. And then we can, that'll be a good thing to do. Okay. So 17 fab BDHS. Okay. All right. It is going to be interesting. Or maybe we can just create a collaborative tool or comparison tool, where comparison document whereby we keep on updating it. All right. Great. Great. So a question from Prashant is where we can access recorded session. Okay. As previous sessions, are available under they're not available under your course. Okay. Okay. Let me just take a look at your account. I saw your email. Let me see tomorrow if we can enable that, right? If there is something wrong with permissioning. Question from Alok, can you suggest how we do these tools practice through Eclipse kind of ID or to do hands-on? Okay. All right. Yes, actually, you can tell me. So before the session starts, you can tell me if you want to record. I can allow you to record. Okay. So you just have to remind me so that I can quickly enable, because there is no way to by default allow all the attendees to enable. Wonderful. So yeah, there are a couple of more questions. One question is from Alok. Could you please suggest how do we do these tools practice through Eclipse kind of ID to do hands-on? So most of the hands-on is going to be, because we are going to go through multiple tools as we go ahead. So the hands-on will most likely be in the terminal. When we have to code, only then we will be either using the notebook or coding on the server using VI or any other editor, or we can also help you with the Eclipse kind of IDE. Okay, so there are two two videos that gives you an overview of how to use Eclipse in our kind of scenario. One is say MapReduce programming. Okay, so because those are the two scenarios where you would need the Eclipse. For rest, you will have to use the individual ID. Okay, now this. Okay, so these are two such example. Now, so what are the UX tools we are going to use? One is we're going to use console. Number two, we are going to use Hue. Number three, we're going to also use, say, Jupyter files slash, there is an editor inside Jupyter also. We'll have to see if that allows. Jupyter Notebook, and of course the console. The fourth interface that we'll use later is by the way of Eclipse, that you can take a look. Okay, wonderful, wonderful. Now, okay, so in this, these are the pre-recorded courses that we have done in the studio. So what I'll suggest is that you go from this side downwards, except for Java Essentials. This is kind of optional. It's not really required. And you can, and Pigletin is also not really required. So you can skip these two, and even Java Essentials, MapReduce programming, and Pigletin. These three things are optional. You can just finish from left to right otherwise. Okay. With respect to coding, it's basically with Spark, we're going to teach you basics of Scala, and that will be sufficient for you. All right. Great, great. Should we start our usual discussion? Okay, there are two more questions. First question is from Maruk. Are we going to do a project for hands-on? Yes. Okay, the base language that we can prepare for coding is, there we're going to use the SQL mostly. Then we are going to use the second project in which we are going to use Scala mostly. And so those are the two projects that we're going to do. Okay. All right. So in addition to the previous questions, David has one more question. So how to start out with the basic tools and graduate to a more robust tool? For example, MySQL DB to HBase. So we will take care of that. We will basically, as we go ahead, that's what we are going to learn slowly. And a question from Prashant is, does these videos cover installing and connecting these components? Yes. Installing, no, because for installing, we haven't covered much in the course. For installing, if you really are interested in installing, you can try the Ambari, installing using Ambari. Okay. And a question from Grishma is that I have similar question as Meruk. Okay. Project which might help us in interview a little bit and we can put on resume. Yes. Okay. So those small projects which we are going to do as we cover more components, we are going to do as small projects. All right. All right. So yes, and I had similar ideas, more ideas on the projects from Prashant. Okay, I met Prashant when I went to Singapore. So okay, wonderful. So let's all right. Should we continue from where we left the last discussion? All right. Okay. So all right. Should we take a break and then come back, or should we just do a recap of HDFS and then we take a break? We do a recap of HDFS, take a break, then we start. Okay. So what we've learned so far is that yeah, we haven't started yet. Okay, but it's a very important part that what we have done is the most important part is to be on in the context, be in the context. Otherwise, as in we should know why we are doing something. Okay, that's the most important part, and I think what we have done today is a good thing, and I'm hoping that it was useful to most of you. Okay, so because the objective is not just to finish the curriculum, but helping all of you learn, that's the objective. So, and that's why it's okay to take digressions. It's okay to take deviations. All right. Now, coming back to it. So what we discussed in the previous session was that the Hadoop file system remains as the heart of the system because this is where the files are stored. Now, Hadoop file system is capable of storing humongous data. Now, before jumping into that, we try to answer the question by ourselves that if we have to store such a humongous data, what are we going to use? And we realized that we could use the standard NAS or SAN, but it has issues. The issues of failover backups and handling such the distribution of data was really uneven and so on. So then we realized that, then we learned that HDFS already does it pretty well. And how does it do? It basically has two kind of servers. One is called Namenode, and the rest are called data nodes. These are basically services running on a port, listening to the request on those ports, the network request. And Namenode is like you have a file system and you have a header of it. Similarly, Namenode just keeps the information about what is where, and that's called metadata. So Namenode just keeps the bookkeeping, as in what is where, while data node actually keeps the data. So Namenode is more like the FAT, file allocation table, of the normal file system. The Namenode basically is kind of keeping the pointers to the data. So Namenode, it keeps in the RAM and data node stores the actual data. So this is what we learned. It's great for storing humongous file, huge data, and so on. The limitation is the first call generally takes a bit of time, while humongous data can be transferred really fast. If there are many small files, then since the metadata increases, therefore HDFS is not great for smaller files. So that's what we learned. And then further, HDFS cuts the data into blocks. Each block is 128 MB, and that's how it stores the data in data nodes. In data nodes, instead of just storing the file, it cuts it into blocks and keeps it on multiple machines. Now, it keeps a copy equal to the replication factor. If one of the machine dies, it'll basically recover that particular lost block from the other blocks. So basically, that's how it works. It basically keeps one copy on the same machine, second copy on the same rack, third copy across the rack. Now, okay, so this was how it recovered from the loss. And then we talked about the driver is basically the one who splits the data, talks to name node, and does the entire work. Driver is the program, the command, and this is what happens. So in case we have multiple name nodes, there will be collisions, and therefore we will never have multiple name nodes. Okay, we talked about reading and writing. The gist was that first call goes to the name node for getting the information, the metadata, and rest, reading or writing, happens directly on the data node. Okay, then we talked about backup. So this is where we were. Okay, so basically the metadata is kept in the memory, and periodically or manually we put a copy, a snapshot of the metadata in the disk. Okay, so we will continue from here after the break. Okay, we'll continue from here after the break. So let's take a break for 10 minutes. Break for 10 minutes. Back by 9:41 p.m. IST. All right, so I'm back. Should we start now? A question from Bintao is that could you give us a brief introduction of Java so that some of us can try some topics on MapReduce basics and MapReduce programming in CloudxLab? Could you recommend us the textbook for Java and Scala respectively? Okay. Okay. And all right. So I would suggest that there is this particular Java essentials that I had created earlier, but we can, this is what I had recorded earlier. And in case this does not suffice, then we can plan a session on Java or something. Okay. So while we will discuss about Scala, as in maybe that before the MapReduce programming, we can plan something. All right. The textbook for Java and Scala, I would actually recommend the tutorials for given on their own website. Those are much more powerful than the books. Okay. So I've actually followed a couple of books on Java, but I ended up using their own documentations. Okay. And the Scala, again, I found the tutorial on their website to be far more better than the books. Now, okay, Sachin's question, it'll be good if we can try out practically more project use cases. Yes. As we go forward, when we go beyond foundation, then we will go into more projects. Okay. And Maruk's question is Scala syntax similar to Java? Yeah, it's kind of between Java and Python. Okay. Yes, we have exactly oops and everything in Scala. Okay. And so on, right? Great. So question was with respect to the one that I really liked is their own tutorial on their website. So here not this. Which book did I follow for Java? I don't even remember which book I followed. I followed like 3-4 books a long back, and afterwards I haven't followed much. So Java reference. So honestly, this is what I generally follow. If I have to look up for something, or Java tutorials. Thinking in Java was good, but I think it's pretty old. Uh, okay, not this one. This specifically collections and getting started. This one is good. And for Scala, as in um, for Scala, what did I use? Not this. All right, good. So Scala we'll learn in the class, and then we will go ahead with the rest. You don't require the Java for this course. Okay. All right. Great. So let's start. All right. So the metadata is kept in the memory, and on demand we create the name image of the same metadata, right? So on the disk is the namespace image. Why is it so? So that the why is it that we do not keep the whole metadata as such in the disk as well? Why? Because that will slow down the metadata operations. Okay, whenever you have to, if you are just updating a file, renaming a file, the metadata is changing, it might take a long time. It'll cause a latency. That's right, Hitendra. Now, on every change, whatever is the change in the metadata, there is a edit log created. Okay, the edit log file is appended by an edit log. So every time we make the changes, the file is appended with an edit log, and that's how it is. So if this part fails, then we'll have to take a namespace image, merge it with edit log 1, 2, 3, and get the current state of metadata in order to recover the name node. Okay, so this way we have backup of the metadata and still it is fast. Okay, so the namespace image is basically a mirror of basically the snapshot of the metadata. It's a snapshot of the metadata that we would schedule to be done on demand. All right, so this is how it keeps the metadata. Okay, now at any point of time, if we have to recover the metadata, if a server crashes or something, we will have to impose the edit logs on top of the namespace image. Okay, so a question from Noor is, we can't have two name nodes, but we can have some kind of HA. Okay, yes, we'll discuss that soon. All right, now the so in case we have only one name node and there is no backup or something, then we can recover it using the namespace image and the edit logs. Now, the second way of keeping the backup is that we keep a copy of the metadata as in the edit log and namespace image, in a network file storage along with the local storage. So in case the whole server goes down, we should still have a copy of the same data. And Namenode provides you a way, a method of keeping the metadata at two places so that it will basically write edit logs at two machines. It'll keep a copy of that. Okay. Now, there was a concept called secondary name node in which we keep a machine ready with the copy of a name node installed on that. And in case of emergency, in case first name node goes down, we prepare the metadata by imposing namespace with edit log and recover the secondary name node. So this method is kind of not really secondary name node. It's kind of, recovering the metadata. There's still a lot of manual work was involved. So this was in Hadoop 1. In Hadoop 2, the failover became really, really well. A question from Sachin is, can you again explain what is namespace image? So periodically, we create the snapshot, okay? Or we also call it image of the entire metadata, meaning whatever is in the memory, we save it to the disk, okay? At this point of time, it keeps a mark that, okay, till this point of time, we have the entire image available. Afterwards, all the changes that are happening, they basically are kept in the edit log. So this happens once in a while because this takes a lot of time, and this we do, let's say, once in a day or once in a week, while edit logs are generated after this point. Okay, got the idea, Sachin? This is in the disk, this is in the memory. This is happening on every change. This image is generated once in a while. It's based on our schedule. All right. Okay, good. Now, at any point of time, the secondary name node can be covered like this, but this is no longer used. Mostly, we used this kind of a failover. Edit log is also in the disk. All right, so this is something very important to understand this kind of architecture. So what we do is we keep two machines. One is name node, other is called standby name node. Okay, now so this is our high availability, or we also call it quorum general manager kind of architecture. So we can, in the Hadoop 2, in Hadoop 2, the HDFS that came with Hadoop 2 had this functionality of creating highly available name node. Okay, how does it work? So you have one machine on which you installed Namenode, correct? You have one machine on which you installed Namenode, then you prepared another machine on that also you installed a name node. So basically you will have two name nodes, okay? But only one of them will be the active one, other one will be standby. Okay, and how will that happen? Basically both of them would write their names in ZooKeeper. In case there is no active, the name no so these are server, let's say S1 and S2. Okay, this one server 1 and server 2, both of them will keep on checking the ZooKeeper. If the current active name node is dead, then they will write their name. So that's the logic. The logic in both of them is exactly identical. The logic is go to ZooKeeper, check if there is any active or not. If there is no active name node available, that means that ephemeral node has disappeared and the server is dead. In case there is no name node, then write your name there as ephemeral name node, and then it will start accepting the changes. Okay. So both name node and standby, they coordinate between themselves using ZooKeeper. An end user discovers who is the current name node using ZooKeeper. Okay. So the idea is the normal name node is not safe. Correct? Why? Because in case name node goes down, entire ecosystem will be dead. Therefore, a high availability system was designed in which you have two name nodes, or maybe more than one name node. There could be three name nodes or four name nodes. All three of them or all of them have identical behavior. They all are exactly same. And the only difference is there is only one active name node at any point of time. Rest of them are standby. Okay, so name node, they will write their name in ZooKeeper. They'll write their name in ZooKeeper, and let's say this was a name node. It wrote its name in the current or the active name node here. And so the way it does it by creating the ephemeral name node now in the ZooKeeper. So in case this name node goes down, it will disappear from ZooKeeper, right? And and therefore the other name node which is standby right now will keep on checking ZooKeeper, and the moment it observes that there is no active name node, so it will write its name in ZooKeeper by creating a Z node, and that's how the coordination between these two would happen. Okay, so both of them are kind of competing for that ephemeral Z node, and that's how. Okay, so the end user will basically, using the client library, will basically query the ZooKeeper, and ZooKeeper will give the end user that who is the current active name node. So both name node and standby, okay, they communicate with each other, and and let's say this is our active name node. So active name node will convey the metadata changes to standby, as well as all the data nodes will inform name node as well as standby about their current status. Okay, so this way both of them remain identical as much as possible. Just that, just that the there is only one active and other ones are standby. Okay, though both of them will have exactly same data. Okay, a question from Robin is regarding the metadata in memory. What is retaining process inside the memory? Does it just override the memory content when full? Okay, so in case the memory content is full, then it starts throwing error that cannot handle any more data. Okay, so that's the behavior of name node, that in case the memory is full, it would start throwing error. Therefore, you need a computer with huge memory for the name node. Okay. A question from Noor. This is fine, but what happens to the data which was not written to the log file yet? Okay. So basically, whenever you're making a change to the metadata, the log file is immediately written. Edit log is immediately written. Okay. All right. Next question is from Aniket. How does standby name node keep getting current info from active name node? From the disk? No, actually they communicate, and as part of their API, the active name node would convey all the metadata changes. Effectively, it sends the edit log to the other other standby. Okay, we'll send the edit logs to the standby. Okay, question from Timir Shah is that how would standby name node know the current status of the active name node by the way of ZooKeeper? Okay, by the way of ZooKeeper. All right. Robin's further question is that in case the memory is full, how do we solve that error? By increasing the memory of name node or by combining a lot of small files into one big sequence file. Okay, that's how we do that. And so that when you have small files, they consume a lot of metadata for small space. Therefore, it is more useful. Let's say you are storing millions of icons or millions of profile pics. So instead of just keeping them as a single file, you combine them together and then store. That way, millions of files will go into a single file, meaning a terabyte of single file. That's completely okay with Hadoop. All right. A question from Grishma is that are the locations same for name node and data node? Name node location as in the physical one? No, they can be on different networks. They can be far away physically. Okay, as long as their ports are open. Ports for data node, whatever is the data node port, I think it's 8020. So if that port is accessible from name node, it's good enough. Same case is true with data node and name node. As long as these services can access each other's port, that's good enough for them to operate. Okay. A question from Robin is, how do we solve the error on full memory? What is the temporary solution before memory upgrade? As I told you that what we do in case of memory full is that we start combining multiple images or multiple small files into a single big file. Okay. A question from Grishma, is there a heartbeat happening between active and standby? No. So heartbeat is via the ZooKeeper. And remember that in case one machine goes down, the ephemeral node will disappear. That mechanism is what is used by these systems. Similarly, if standby wants to get notification as soon as the ephemeral node disappears, it can create watches. It would create internally the watches to watch whether a particular node has gone down or not. Okay, so using ZooKeeper, they are able to coordinate pretty well. All right. All right. So a question from Grishma is in case of memory, want the data which is unused for a long time be replaced by newly queried data. So, okay, let me be very clear. What do we have in the memory? What do we have in the memory? Memory contains the metadata. What is metadata? Name of the folders, name of the files, where is that file located on which servers, and so on. That is metadata, and that's what is kept in the memory. Okay, so whenever we make a change to the file, it always go through the name node, and therefore it is always replaced and updated with the newer data. Okay, so yes, and of course the garbage collection would be there. That's a part of Java virtual machine. So name node, whichever memory it's not using will be delocated, and newer memory will be located. That's a part of JVM standard. And any software that uses JVM has the same behavior. Okay. A question from Robin: what's the ideal memory capacity for name node? They say something like 64 GB minimum, but it all is a function of what is your requirement. Okay. So you must do a capacity planning in terms of number, like what kind of data you're planning to give to, what kind of storage you plan to give to all the users, and keeping the replication factor in mind, you should plan. So generally, every machine, let's say you have 15 machines, okay? So, all right, let me just try to answer this question. It's a very important question. Question is, okay, what will I consider into this? Okay, the main thing that you should consider is the amount of space that you are giving to the end user. Okay, okay, that you are trying to build. Okay. Also, you must know that every file is going to create an entry in the metadata. Therefore, we have to keep in mind that the kind of memory we are going to have for the say name node is going to be say 64 GB or 32 GB. Okay, so it's a humongous kind of memory that we generally give, and as and when the usage of your name node is going up, you should keep an eye on it. In case people are creating just too many files, too many small files, you suggest them to basically zip them together and put them in, uh, put after zipping them together. Okay. So with respect to capacity, generally you plan the capacity of data nodes. So, and you should keep in mind the replication vector that you want to give. And 80% of local disk is generally given to data nodes. Okay, but but all of this is configurable. You can make it like 90% or something. And so if you have say 5 machines, each with 1 TB, and then this and this. So if 5 machines, each of with 1 TB, would be able to give you this much of space on 1.3 total TB. Okay. So if you have 3 replication factor for 5 machines and you are giving 80% of the machine to the HDFS data node, then this is the net amount of terabyte that you'll get. So instead of 5 terabyte, you'll get 1.3 terabyte. All right. A question from Robin: what are the manual and automated update process on name node contents? What component pushes the update changes on the name node content? All right. There are quite a few questions that I would like to answer. Okay. Right. Now, yeah, a question from Noor. So there is no way to scale name node. I'll just talk about this after a while. We have a mechanism there. Question from Robin: what are the manual and automated update process for name node contents? Okay. What component pushes the update changes on name node content? So whenever we are whenever we are changing a file, it's actually changing the name node contents. Okay. Renaming a file, uploading a file, deleting a file, all of that changes the metadata and hence updated. And okay, is that your question? Have I understood your question correctly? So what do you mean by automated update process? So anybody can call the API of name HDFS in order to talk to name node. Okay. Who splits the file into blocks? The client driver. Okay. Who splits the file into blocks? The client driver, as in the software that is provided with the name Hadoop FS is the one that splits the blocks. Okay. Question from Grishma, extending nodes question. Amazon and Google data will be huge and changes will keep happening. How will Namenode work here? We'll talk about it soon. Okay. Question from Subbu is, if ZooKeeper is not in place, how would this coordination happen? Which tools can we use? So basically, there is something called Quorum General Manager, and by default it uses ZooKeeper, but there are some more tools like ZooKeeper that Quorum General Manager can can basically support. Okay, good, great set of questions. All right. Right. Great. Now yeah. So basically, this is to avoid name node becoming single point of failure. In case name node goes down, standby takes its place, and once the name node comes back again, that one will become the standby. Okay, while this one will become the active. So that switching between name node and standby will be automatic and would happen through ZooKeeper. And please note that both the data nodes, okay, the same data nodes, they will both send the information to name node and standby. Now, there is another concept called HDFS Federation. What does it mean? It means that in case you reach to a situation where one name node is not able to suffice, then what you do is you have two name nodes, and maybe the standby for both the name nodes, and these name nodes use the same data nodes to store the data. So basically, data nodes space is pulled in by name node 1 and name node 2, while this behaves like two different file systems. So we have two name nodes, name node 1 and name node 2. Both of them will basically have their own file system, which is different from each other. So they have basically these two are two different file system and two independent file system. Okay, and then the only twist in the story is that they use the same data nodes. Okay, so data node keep a track of which block came from which name node. Okay, they basically, the way they design the ID, the name of the block ID, they keep a track whether the block came from name node 1 or name node 2. So that's how the HDFS Federation solves the problem of name node memory becoming full. Okay, because data node disk cannot become full, because if let's say that the whole cluster is about to become full, you can add more and more data nodes. Okay, so you don't have to worry about this part. Okay, but in case name node is full, the metadata is not coming anymore. So what you do is you create another name node. So they become like two separate file system. And and at the client library level, we create something called mount point table, where we keep a configuration that this directory, request to this directory goes to this particular name node, while the request to these directories would go to this. So we we basically, the client library consult this mount tables. Mount table is nothing but local files. So, and these local files are made available on all the machines. So when the moment you install a new name node, what you do is you update the mount tables on all the machines. So when the user uses the client library consults the mount table to check which name node to go to. And which name node to go to is a function of which data, which folder are we accessing. Okay, so if, for example, here my data one, the request for my data one is going here, while my data two and my data three, the request is going to go here. All right. So both of the name node will have their own backups, and there will be a pool of data nodes which will be serving both. All right. So question from Robin is, what are the criteria for automatically electing the primary active name node? Okay, you mean the previous architecture here? So basically here the idea is pretty simple, that first you will basically, both the name node and standby are identical. Okay, you will just make one of them as primary, or you just turn them on. Whosoever takes the slot takes the slot. So they do the switching between themselves. Okay, using ZooKeeper. So in case name node goes down, other one will come up, this first one will become standby, and so on. So that switching will keep on happening automatically. All right. So with respect to the federation, this is federation where you have multiple name node. The load balancing or distribution of work happens based on which folder we are accessing, or which folder we are trying to write to, the top level folder specifically, and that's how the HDFS federation work. Yes, so mount table is a mapping between directory and name nodes. Every client have the same mount table, correct? So we basically have to keep updating the mount tables in order to avoid the disasters. Okay, great. So the entire metadata is in the main memory. Okay, this is what we have learned so far. The types of metadata is basically the various kinds of metadata that is kept, which is list of files, the name of each file, list of blocks of each file, the list of data node for each block, file attribute like access time, replication factor, file size, file name, directory name, then transaction log or edit logs, records, file creation, file deletion, etc. Okay, so this is what metadata has. A question from Minta, does each client have his herself name node? Can they have the same data node? Okay, so you generally define the name nodes for organizational level. Let's say your name node is about to become full and you realize that the only way we can survive is by having one more name node, right? If you have many more users accessing the same file system, then you might end up with name nodes memory becoming full. So you might want to divide it into two parts. This is really rare. And so the way it happens is that we maintain these files which contain the mapping between name node and the folder structure, top level folder structure specifically, and so on. A question from Mintaur, does each client have, okay, can they share the same data node? They basically, name nodes share the same data nodes. Yeah. the same data nodes, just that while saving the data, the identification of each block is based on the name node. Okay. Question from Grishma, transaction log entry contains what exactly? Yes. So transaction log entry is basically edit log. Question from Noor is, why do we have to have pool of data nodes when two name nodes don't share data node? No, the name nodes are sharing the data nodes. Okay. Name nodes are sharing the data nodes. All right. Since data node has already have the space, it just the name node's memory was full, so we needed two name nodes, and therefore we can use the same data node. That's a part of the architecture of the HDFS. Again, it came in HDFS Federation was enabled in Hadoop 2. Question from Grishma, multiple name nodes won't be a bottleneck. I mean, in case same file has multiple blocks and each block entry on different name nodes. No. So one file will always be at one place. It won't be at two name nodes. Okay? Because the mapping between the folder and name node is there. So one file will be on one name node. All right. So practically these are two separate name nodes. Basically you can look at these as if they are two separate file systems. So practically they are basically two separate file systems. All right. Another question from Grishma is that if data gets added to the file, it's handled by name node. So whenever we are so if we are sending a request to name node that we want to append to a file, then we need to basically inform name node that we want to interact with the file. And the actual appending of the file happens on the data node. A question from Noor is, how does metadata look like? Is it like SQLDB or NoSQLDB or just like a file? It's basically a block of data. Okay, it's basically the block of data. And it's not in the format of some standard database table. It's basically is kept in the memory of name node. All right. I doubt if we can inquire it other than looking at the edit logs. Okay. All right. So let's do some hands-on. Question from Hitendra is, name node is like ZooKeeper of the data, kind of, yes. So like the way name node, like ZooKeeper only keep very tiny small of data. The name node also keep the metadata only, not the actual data. Okay, so yes. All right. So this we have already discussed. And so let's say I would like to upload a file. So the only thing we are going to do is we are going to upload the file, change the replication factor, and take a look at the data blocks. These are the three things that we are going to do. Okay, let's do that. So Okay, so what I'm going to do is, let me just update it so that it makes more sense. All right, now let's say there is HDFS, there is everybody's clear, right? So there is HDFS and there is CloudxLab console and there is your laptop. So there are three file systems that we'll deal with. And to start with, we are going to take a look at this file, sample.txt. So how should we start? Okay, let's go to our CloudxLab My Lab. We'll go to My Lab. And here, if you go to the web console, or we can just go to Jupyter. So this is one file system. This is our local file system. Okay. While if you go into Hue, okay, the file system that you see under file browser, this is HDFS. You see my home folder here? This is my HDFS. Now, take a look at it. It's just like normal file system. It's like normal file system. So if I'm deleting these folders, who is going to be informed? Who's going to be informed? Name node or data node or both? Okay, because they would have the files also, right? They'll have files also. So both will be informed. Okay, so basically when I delete a file, the data nodes are also going to be informed that this particular block is no longer needed and therefore discarded. Okay, so I'm going to delete these folders. I just have too much of files gathered here. You can see. All right, you can create a folder. You can try creating and uploading from your desktop. Okay, so I'm just deleting this. All right, so there is a file called today's notes, right? Let me just upload it to HDFS. Okay, so let me first create a new folder or a directory, and let's say, or let me just upload it just like that. Okay, so I'm saying upload and I'm clicking on files, selecting the files, and where was the, okay, so it has uploaded the file from my local file system to HDFS. Okay, so this is what we did. Uploaded from my laptop directly to HDFS. Okay, so this is what we did. Try uploading a file, local file, into HDFS using Hue. All of you, keep in mind that you have permission to change only your folder. This is your home folder. In case you go to some other folder, you can always click on home folder to come back here. Are you done? Yes. So this is the file I have uploaded. You can see that it has uploaded here.
Sandeep, I am not able to log in into Hue. Can you please check Sachin?
Okay, Sachin. Can you message me, send me in private?
Yeah.
Okay. Uh, the private message with your login and password. Okay. All right. So let me just try. I'm able to log in. Can you see Sachin? When you click on file browser, then you will see the file browser. And here you can upload the file. I just copy pasted whatever you copy pasted to me, and it worked. Just go to d.cloudxlab/file browser and that should work. All right, Sachin. Okay. A question from Shravanti was, I have uploaded one file which was on my desktop, and after clicking on that, it is showing page not found. Okay. Do you want to uh, show the desktop so that I can take a look at it quickly? Okay. Could you share the screen, please? I see. Because I think there is a space in the name, and I think the Hue is not able to handle the spaces in the name. Okay, click on the name. Show me. I see. I see. It's not able to handle the spaces in the name. Okay. There's some kind of a special character. Okay. You can just try deleting. Does it work? Deleting works. Move to trash. Oh, it did work. Okay. Try renaming the file locally and before uploading. Okay. Actually, there is always these character problems, the special character problems with Windows and Linux that generally. Okay. Yeah. Content is encrypted as in because it could be a binary data. .doc file cannot be opened by any other editor other than the Microsoft Office. Okay, that's the reason why it looks like it is encrypted. Okay, all right. So Hiten's question is, I was able to upload from my desktop. Can you see it? I won't be able to see unless I either log in into the admin account or log in into your account. Okay, great. A question from Subbu, can you explain how to upload the file from Unix console? That's what I'm going to do now. Okay, so, all right. Yeah. So question from Bintao, I've just uploaded PDF. How can I open it with Hue? Hue does not let you open PDF. Try uploading simple text files. Okay, great. Now, let's try the second part. Second part is we using the console, we will interact with HDFS. Okay, we will interact with HDFS. So whatever file we uploaded in the first step, what was the name of that file? Okay, this was the file, right? So now we will log in into console and download it locally. Okay, so let me just go back to my console. I'll say terminal here. I prefer Jupyter's console because there I don't have to log in again. And here I'm already logged in. Now, so here when I say ls17 asterisk, there is no file, the name of which is starting with 17, meaning this file is not there locally. Okay, it's not there locally. Okay, it's not. All right. So what we have here is the file which we have uploaded in HDFS is here. So now let me just try copying it. Now, this is a more important part. So to interact with Hadoop, we generally use the console. Okay. To interact with Hadoop file system specifically, we generally use the command called Hadoop space fs. Though there is another newer command called HDFS, which is same, but for compatibility reasons, backward compatibility reasons, we are just going ahead with Hadoop FS. Okay, Hadoop FS is a command. This is basically the driver that we have been talking about, Hadoop driver that we have been talking about. So it lets you interact with the file system. Okay, Hue also have its own internal driver to HDFS. When we uploaded something, it basically talked to the name node and stored the blocks in the data node and so on. Okay, so you can see that when we say Hadoop fsls, okay, so you can try this command in the console, either normal console or inside Jupyter, either of it. Okay, you should see the file that you uploaded earlier. So there is this file that we are having here. Okay. All right. While ls, when I do, it says no such file, because ls is talking to this machine. And what is this machine? This machine is on e.cloudxlab.com, and this is my local folder. Okay, this is on the local Linux folder, while Hadoop FS is talking to HDFS and then showing you the detail about this file. Okay, so now what if we have to bring this file to my local machine, this e.cloudxlab, this console? If I want to bring this file from HDFS to local, what will I do? I'll say Hadoop FS. Instead of ls, I'll say get. Okay. Either we say get or we say copy to local. Okay, now when I say ls this file, it is there. You can see. Now it did not say file not found. Okay, a question from Bintao is that what formats can Hue open? I think it can open .txt file, .zip file, and I think image file also, but not the other files. Okay, another question is we don't why don't the size of directory shown in Hadoop? It is shown here. Directory size is generally not shown to anybody, but you can use a command called Hadoop FS and DU. Okay, using DU, you can find the size of a folder. Let's say my model, right? I can find the size of my model folder using DU. Okay, so we talked about three commands so far: Hadoop fs-ls, Hadoop fs-get, and Hadoop fs-du, right? Okay, a question from Noor: is the user mapping in HDFS done after installation of Hadoop, or this is automatically provided by Hadoop? So the way Hadoop file system work is in the usual mode, in the non-Kerberos mode, in the non-secure mode, the local user, whosoever it is, it, the user will be identified by the local username. Okay, so you don't have to do much. You just can create you just whatever is the local username, you log into your own account, and then you can interact with HDFS. Okay, so all right. So similar to get, there is another command which is identical to get. It's called copy to local. Copy to local. Okay. It says that the file already exists. In case you want to find out what are the various commands available, you should say Hadoop fs-help. It shows you all the commands that are available to you. Okay, you can see put, you can see get, you can see so many other things. All right. A question from Noor: I mean the user folder in HDFS were created manually, or these were automatically created based on the local users in Unix? Yes, they were automatically created. So we had to we had to call an API there to create these home folders. Okay. All right. So are you able to get the file? All right. I'm going to rename the file locally. Okay, this was the file I downloaded. Okay. I'm going to say move this to say, so the file that I copied locally looks like this. Okay. And then we are saying Hadoop fs and put this one. Now, we basically all we did was we just renamed this file to something else and then uploading a new file to HDFS from local. Now, from here, from the console, if we say put or copy from local, then it'll basically upload the file. Okay, upload the file. Let's take a look. If I just sort my data based on the date, it should show us the two files. Okay, this is the one that I uploaded from console. This is the one I uploaded using the Hue. Okay. A question from Subbu is that most commands print help when invoked without parameter. That's right. So here, when you say this, a get hotandworks.txt, no such file. That means in the HDFS, there is no file called hotandworks.txt. Okay. So when you're saying Hadoop fs space dot dash get, probably that file is not existing. Grishma, do you want me to show the screen? Okay. All right. I'll just stop the video. You can share the screen and click on the share the screen. What is dash du? Du shows the disk usage. How much is the file? How much is the space being used by a particular file? Yes, go ahead, Grishma. Please share the screen. This is a screen share option. Okay. Yes. All right. So, okay. So you're saying you're trying to, let's say, copy which file? The last one? Okay. So the console. Please note that yeah, I think it is small s in the sample. I think that's the problem. The command is correct. Cool. So if you say ls now, ls, no normal ls. So you can see there will be a local file with the name sample2.rtft. I think that's a red color. In the fourth column, first file. Yes, that's right. So you can see that it has brought the data locally. Okay. So that's pretty much. Anybody else stuck?
Sandeep, I have a question here.
Mhm.
Is it like we should remove the spaces?
Yeah, if you're not removing the spaces, put that in double quotes while interacting from the command line.
So here I have another file.
Oh, you have to share the screen. Okay.
I
You
did
have
actually.
another file?
Okay, let
Good.
me.
Yeah, no, I can see the screen. Yeah.
Okay. I mean, suppose if I want to get this file,
Okay.
just copying the name.
Yeah. Put the double quote around it.
Oh, okay.
No.
It got copied twice.
Okay.
So like this.
Yeah. I think it's getting the data.
Okay.
All right. So, all
Yes,
right.
it got created. Thanks.
Great. 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 All right. So, okay. So, Subbu, you can share the screen. Okay. So for you, it's saying the, all right. All right. Go ahead. Let me take a look at the hue, the fourth folder for fifth tab. Okay, so it is in that particular folder, right? So you have to specify the folder also. Okay. You have to specify the folder also. Yeah? Go back to the console. Then go back to the console. Yeah, this is good. This is good. Okay. Say Hadoop FS, Hadoop space FS. This is spelling mistake in Hadoop. Space FS space dash ls. Just say ls first. Okay. Now there is this folder here, right? So you can say, just copy the name of the folder. Okay. Then you say Hadoop space fs space no dash there. Yeah, get space. Now paste the folder name slash asterisk asterisk. Enter. Now say ls. Will bring all the file from that folder to your current directory. You can see heartandworks.txt. Great, great. All right. So this way you can interact with HDFS from the console. All right. Okay, so there are some questions. Let me go one by one. Question from Minta is how to check the path of Hadoop file in Linux/console. Hadoop file from Linux console. You can just say Hadoop space fs and then followed by ls. Is there a special directory built in by us or Hadoop? Is there a special directory built in by us? So every user has their home directory. That's a special directory for every user. Okay. And when you do not specify the absolute path, it considers it to be relative to your home directory. Is that your question? Okay. Are you able to create the file and folder, the one that we were discussing? Are you able to interact with HDFS using Hadoop FS command? Great, great, wonderful. A question from Alok. When we say get it, it will collect all the blocks from all the data nodes and copy it into local machine. Yes. So the moment we say Hadoop FS get, it basically brings all the blocks from all the data nodes to your local machine. Correct. First, it is going to Hadoop FS get is going to go to name node, talks to name node, then gather the details about the blocks and bring it back to you. Okay. Question from Noor. What is the way to upload file to another user's folder instead of home folder? So you can basically define the target folder in the put. So you can say that I want to put in this particular folder. So that is the last argument. If you skip the target, then it will upload everything to your home directory. Okay. Yes, that's right, Sachin. When we do Hadoop FS get, it will take a copy of file from HDFS to the local file system. That's correct. Great. A question from Noor is, what is the way to upload folder to another? Let's say we have my model folder here, correct? Let's say we have a my model folder and we would like to upload there. Okay, so let me just create a file called sample.txt. I'm using this nano editor. This is a very simple file. I'm using a very simple editor. Now I'm saying Hadoop fs put sample.txt, and I'm going to upload it to my model. Okay, so you can see that it has here in the hue, if I go to my model, it has uploaded my sample.txt. Okay, all right. So quick question from Grishma is that how to copy all the files? You can just say the way we did just now, Hadoop fs-get, and then we say asterisk. Okay, then it will bring all the files. A question from Middaw, can I use the command of Hadoop fs-get to save to a specific file? Yes. Okay, let me just show you that. Let's say I'm trying to put at an absolute location. Let's say inside TMP folder in HDFS, we would like to upload this file. Okay, it says sample.txt already exists in temp. Okay, so what I'll do is I'll just rename sample.txt to sample underscore sg. Okay, let me try again if it is allowing me to do that. Nice. So it has uploaded my data, this file into this particular folder in HDFS. Let us take a look using Hue how to go to /tmp. I clicked on the slash at the top level and then clicked on tmp. And if I sort the data, so you can see that it has created inside TMP folder. Okay. All right. A question from Grishma, when I say get, it is basically doing this. Interesting, interesting. Okay, so I think basically it's completing the asterisk to the local directory. If you put asterisk inside double quotes, is it working? Let's say let's say I had a folder called my model, right? I'll just click on home and then go to my model, right? I'll sort my data based on the date. And let's say all of these files, I would like to bring it to the local, right? So what I could do is I could say from here, Hadoop fs -get, Hadoop fs -get, and I'm saying so for me it seems to work. Probably you might want to put a double quote. So put, or you can also use Hadoop instead of put. You could use copy from local, or in case you are moving files, a more efficient command is move from local. Okay, you will be able to see that. So there are many commands here. Okay, one of them is append. There is put. You can see put. It copies files from local file system into file HDFS. Okay. And there is move. Okay, and I was talking about move from local, right? Move from local is quite important command. If you have a humongous file that you are trying to upload, say few GB of file from local machine to HDFS, right? So instead of copying, you should move. All right. So that's pretty much for today. So we will continue from here. In the meantime, try using these commands, and then we will continue from the blocks in the next session. All right. See you tomorrow at the same time. Have a good day. Bye-bye. Thank you, everyone. Bye-bye. Have a good day. Thank you, Noor. All right. Bye-bye. Have a good day. Looking forward to see you tomorrow.